Okay, so now we come to the second part of today's synchronous lecture. Alright, we stay in continuity of a function, and we will discuss some rules regarding this continuity. Okay, so it is stated that if f and g are continuous at a point A, then the following functions are also continuous at A. Okay, assume c is a constant and n is more than 0, is an integer. So if we have function f and g, so both functions are continuous, then the addition of these two functions f plus g also continuous. Same goes for f minus g. And if we have a constant c multiplied with a function f, given that f is continuous, then c times f is also continuous. F times g also will result a continuous function if both functions f and g are continuous. Same goes for f over g or f divided by g, given that provided ga does not equals to 0. And fx power of n will also be continuous if fx is continuous. Okay. As for polynomial and rational functions, polynomial function is continuous for all x. Okay, so maknanya ni hukum dia. You tahu tak apa itu continuous function? Okay, continuous pula. Polynomial function. Polynomial function ni maksudnya is a function yang ada power tu. X power of n plus x power of n minus 1 dan next sampai lah x power of 0. Ataupun kita ada a kat sini, b and then z whatever lah. Maknanya macam yang ada power, integer power. Okay, fx equals to x power of 5 plus 4x power of 3 plus 2x power of 2 minus 5, for example. Okay, this is one example of a polynomial function. So if you come across with this kind of function, it is understood that it is continuous for all value of x from minus infinity up to infinity. Okay, and then for b, we're done with a. For b, a rational function, a function of the form p over q, where p and q are polynomials. Okay, this function, a rational function, also will be continuous for Lx, for all x, given that qx, the denominator ni, is not equals to 0. If our denominator equals to 0, then we will have trouble, or the function may not be continuous. Okay, for example, kalau we have a function fx equals to x plus 1 over x minus 1. Okay, x plus 1 over x minus 1. So you see this function, okay, we have a condition where, okay, this thing will become 0 when x is equals to 1. So at this point, x equals to 1 is our discontinuous point. Okay, the function fx will not be continuous at x equals to 1. The rest, it will be continuous. Maknanya dia punya domain of continuity will be, kalau this example, maknanya dia punya domain of continuity will be negative infinity to 1, exclusive daripada 1 up to infinity. Maknanya 1 ni dia jadi breaking point. Okay, the breaking point. Dia tak termasuk. Okay. Okay, and then we have continuity of a composite function at a point. At a point. Okay, if f is continuous at a and f is continuous at ga, then the composite function f, okay, composite g is continuous at a. Composite function, kalau tak silap dalam bahasa Melayu dulu, you all panggil apa fungsi gubahan, betul tak? Okay, remember this function? Katakanlah given to you fx is equals to x square, and then gx is equals to x plus 1. Okay, so if we say f gx, okay, then will become apa? Dekat x square ni kita akan ganti dengan x plus 1 everything square. Okay, we replace x inside fx ni with gx. So x become x plus 1. So you become x plus 1 square. Ingat tak yang ni? Okay, saya ingat rasanya masa SPM at Maths Code you ada belajar pasal benda ni kan. Unless my time last time lah, unless if the syllabus revise, saya tak tahulah you belajar masa bila. Okay, so meaning to say for this kind of example, if fx is continuous and gx also continuous, then its composite function also will result in a continuous function. Faham It will also result in a continuous function. Okay, and then next we have continuity of a function with roots. Assume that m and n are positive integers with no common factors. With no common factors maknanya tak ada factor yang kita boleh simplify. Okay, if m is an odd integer, then fx and m over m is continuous at all points at which f is continuous. Okay. Yang ni rasanya is easy if we will discuss through examples later on, hopefully. Okay, and then here yang ni sebenarnya we have discussed in example 13. Okay, continuity of a function, continuity from the right, two-sided continuity and continuity from the left. Saya dah cerita tadi kan. Okay, so hopefully all of you will understand lah. Okay, definitely you don't have any problem to understand this. Okay, continuity maknanya yang ni kita panggil it is continuous from the right of A. From the right of A, because kat sini limit fx as x approaching A from the right. Curve ni coming from the right is equals to FA. So it's continuous from the right. Yang ni pula, okay, kita go for the end point first. Continuous from the left. The curve coming all the way daripada left side of B. Okay, so meaning that limit fx as x approaching B from the left is equals to FB. Only from the left side the continuity, the function is continuous. From the right side tak ada. Okay, and this one no problem because it is pointing to the same point and is defined. So maknanya kalau kita nak tulis interval of continuity macam yang saya cakap tadi, maksudnya dia continuous from the right of A. So kita ada close bracket. Okay, and see, do I need to write down here? No need, because it's inclusive. Dia memang continuous, so it must be within the domain here. It's understood. Okay, and goes to B. B open or close? Yes, it's close bracket as well, or square bracket here. Maksudnya B is inclusive. Maksudnya it's continuous from the left of B. Okay. Okay, so as I said before, a function f is continuous from the left kalau limit fx as x approaching A from the left is equals to fa, and f is continuous from the right if limit fx as x approaching A from the right is equals to fa. Okay. Okay. Okay, so we have here next one, continuity and at an interval. Okay, so it's mentioned a function f is continuous on an interval I if it is continuous at all points of I. If I contains its endpoints, continuity of on I means continuous from the right or left at the endpoints. Okay, so this one meaning indirectly we have discussed before towards the end of example 13. Okay, where we want to determine the interval of continuity. Okay, so for example here we have a function or we have a graph here. Okay, that is sketch for you. Ni kalau you nampak ni sebenarnya adalah a semicircle, right? Where gx is equals to square root of 9 minus x square. Okay, so as you can see here, okay, continuous on negative 3 to 3 inclusive. Okay, square bracket negative 3 to 3. So meaning that at end point it is included from the right of negative 3 and from the left of 3. Nampak tak graph ni? So, okay, right continuous at x equals to -3. Maknanya the curve is coming from the right of -3 pointing to -3, and -3 is defined as well. Okay, and then 3 pula, the curve coming from the left of x equals to 3, and limit, so meaning that limit as x approaching 3 is equals to 0, and f3 also equals to 0. So that's why dia punya interval of continuity is -3, 3. Okay, so example 14 ni pun very simple lah. Given to you, if fx equals to root of 4 minus x square, sketch the graph of y equals to fx and prove that fx is continuous on the interval -2 to 2. So maknanya kat sini sama je dengan graph yang ni kan, because this just a different. Yang ni 9, yang ni 4. So meaning that this one is also a semicircle with the radius of apa? Radius of, tak cantik pula saya lukis ni. Okay, with radius of 2 here, -2 here. Okay, so we draw lah approximately a circle here. So, tengok lukis circle pun herok petok orang Kelantan kata. Okay, so this one is radius is 2 kan, so maknanya kat sini pun 2. Okay, so we have a point here, -2. When x equals to -2, put inside, fx will be 0, 2 also 0. So to prove that it's continuous in the interval -2 to 2, maksudnya you buktikan lah limit, okay, fx as x approaching -2 from the right is equals to 0 and is equals to f2. Sorry, f -2. So meaning that continuous from the right of x equals to -2. And then another one, you prove that, show that limit fx as x approaching 2 from the left is equals to apa? 0 as well, which is equals to f2. So meaning that is continuous from the left of x equals to, tak tulis kat sini, x equals to 2. Okay, so that's why, okay, having said that, we have interval of continuity is -2 to 2, sebabnya dia continuous from the right of -2 and also from the left of 2. Okay, then here we have intermediate value theorem. This one I think lah, it's just a theorem, mention that suppose f is continuous on the interval a, b, maknanya continuous from the right of A and from the left of B, and L is a number between FA and FB, then there is at least a number C in AB satisfying FC equals to L. Okay, FC equals to L maksudnya dalam within this domain ni adalah function yang C ni adalah value of X di dalam domain A to within the range A and B. Di dalam domain A, B ni ada value of C. So maknanya we know that at point C is continuous. So if point C is continuous, meaning that the value is defined. Okay, and X equals to C will equals to a value L. Okay. Yang ni pun samalah. Okay, we have here C. Maknanya what they're trying to say, as long as the function is stated that, katakanlah soalan is mentioned that function tu continuous dari -4 hingga 4. So maknanya is understood whatever value within this range, katakanlah x sama dengan negatif 2, kosong, 2, 3, apa semua, all this value is continuous. Maknanya kita ada value f negatif 2 ada value, f kosong ada value, f2 ada value. Kenapa? Because it's continuous. Kalau continuous maknanya the function is defined lah. Okay, tu je nak bagi tahunya kat sini. Okay, if mention that f is not continuous on a, b, then maksudnya adalah point kat dalam ni yang breaking point dia. Okay, there is no number c such that fc is equal to L. Okay, maknanya ada value yang mana fc ada value yang kat situ is not defined ataupun limit dia tak exist because it's not continuous. Alright.